Okay, we're going to do a three-dimensional print of a multimeter, and this part will show up in color just as it shows up on the screen here. It's going to print in layers, and it's going to take 1 hour and 57 minutes to build it in color, and it's going to print it in 413 layers. The way this machine works is it's essentially just like an inkjet printer. It pulls ink, in this case the ink is substituted for a binder agent, through these hoses. The carriage moves side to side and back and forth, and you have powder that's fed from one chamber to another chamber. As this chamber raises the powder level, this chamber lowers and fills up with powder. One layer at a time, the model will be built. As the arm comes across, it'll grab a layer of powder and print the layer, the model one layer at a time. And you'll see as it starts printing, you'll see just one layer of color appear. And the powder just feels just like cornstarch. This is spreading the powder in a thin layer to create a base for the model to be built on. You'll notice as the model is printing, it's printing a border, so it doesn't print a complete solid. It makes a filled part, making the best use of the powdered material. And as the model prints, it's getting lower into the build chamber, and so eventually when the model is complete, it'll be buried within the powder, and you basically do an archaeological dig, which we'll show later, to excavate the part and pull it out of the powder material that's left to support it as the part dries in the powder. You'll notice the color is starting to appear in the model, and also the way the software works is if there's a hollow part, it'll build a outline, so as the model is sliced by layers, you'll just see a ring, or it looks like a hollow part, but it's basically connected by the border geometry. One of the benefits of this printer is that it actually has the capability of printing text right into the model, which is doing right now on the screen of this model. Okay, the part's now completed, and I'm now going to remove it. Normally there would be a vacuum running to remove any of the ambient dust from the area. I'm not going to run that so that we can hear what's going on and what's being said. First thing I want to do is lower this chamber, which is the feed chamber. And I'll let that drop. The model is sitting right now buried in here. And what I'm going to do is use various tools to remove the model. The next thing that we'll do is bring the model into the vacuum chamber, and what we do is we use compressed air and basically blow the part off, clean up all the excess powder, and then use a form of cyanoacrylate glue or CA glue, super glue, to infiltrate the model to harden it. Right now it's very brittle. It's durable because it's a pretty solid part, but more of the fragile models can break very easily at this point. So we use a super glue to infiltrate the part, makes it much more strong, and you can actually grind it with a Dremel tool if you want after that's done. So I'm going to blow this off, clean up the part, and get ready for infiltration. Technology is a Dimension 1200 machine here, and this machine has just printed some parts. Now the difference here is these parts come out of the machine fairly substantial in their structure. They can be used as models that have some durability. The machine prints a layer of support material, and it's an ABS plastic. In this machine, it's actually a heavy-duty ABS plastic, and it is melted through a laser head that's up in this corner of the machine, and it melts the support material and the ABS plastic through the laser. And again, it builds over a layer through time and space, and actually fills up the chamber. This machine has a smaller build envelope than the Spectrum 510. That machine can build a part 10 by 14 by 8 inches. This machine has a build envelope of 10 by 10 by 12 inches. The Spectrum is a color machine and a much faster machine. This machine prints a much more durable part, and again, it is monochromatic. You can print multiple colors, but you can only do that one at a time. Another piece of equipment that we have at our disposal is an Objet Alaris 30, which is a UV cured plastic material prototyping technology. What it does is it uses UV light to cure this very thin material, and it has, again, a smaller build chamber. This one's only about 8 by 10. And it cures through an ultraviolet light, a layer, but it's a wider swath of light that cures while the machine is processing the part. The benefit here is actually this part is printed. It has a much more durable, much more reflective surface, and it has a very great degree of precision and accuracy in terms of the resolution of the part. This machine printed this part, and the support material is basically washed away with water. The parts are, again, monochromatic. They're not meant to hold up to much pressure, so they're a little bit more fragile than in either of the two other technologies. But again, it's a much more reflective surface and much finer resolution in terms of the finished part that you can get. Another machine that we have at our disposal is the Universal Laser. This is a 32 by 18 inch bed. It's a flat bed laser. This machine will cut up to an inch thick material, generally used for porous materials such as wood, leather, but we've used it to cut glass. It can etch. Anything without a reflective surface can be cut on this machine. It's also good, you can actually cut plywood and basically scale like a plywood frame as if it was an actual furniture frame, which we did here. So if this was a a frame that was built out of 7/8 plywood. We've scaled it down, cut it out of 1-inch plywood, and essentially duplicated an actual frame. We think this is another piece of equipment that is very useful in the rapid prototyping technology.